Good morning, my dear students. Today, in this video clip, I want to discuss about the particle move in a two dimension. It means two-dimensional motion of the particle. Before going to discuss about that point, I want to request to all the students to become a subscriber for our physics channel. How you become a subscriber for our channel? You press that subscriber red button and you press the bell button. You become a subscriber for our channel. You got directly our video clip in your mobile YouTube. Okay, thank you. I hope all of you become a subscriber for our channel. Yes. No, in the previous video clip already I have discussed about that is the two-dimension motion. Two-dimension motion, it means once the particle change the position and change the coordinates, there is only one coordinate in a particular plane. It is called two-dimension motion. When a particle move in a two-dimension with change in the coordinate, two coordinates, for example, you take the xy plane. In the case of xy plane, it is only change the coordinates x and y. There is a change in the coordinates x and y. Suppose it is moving a yz plane, change the coordinates y and z. If it is moving a xz plane, at that time change the coordinate x and z. And one more, you always express the different things, that is the position vector. You express the position vector. When you express the position vector, it is in terms of r. Suppose you express the distance or a certain displacement represented by r, it indicates the motion of the particle is in two dimension or you said to be three dimension. Now, the particle at one particular position in xy plane, at that time, position vector is represented by vector r. Now, vector r is equal to x I cap plus y j cap. Now, I cap and j cap are the unit vectors along x and y axis. This is position vector first. And what is the magnitude of the position vector r? R is equal to under root of x square plus y square. Already I have discussed these points in the previous video clip. Position vector is vector r is equal to x I cap plus y j cap. And its magnitude r is equal to under root of x square plus y square. And direction tan theta is equal to y by x, tan theta is equal to tan inverse of y by x. This is about position vector. First thing. Second thing is displacement vector. Once change the coordinates both x and y, the particle covers the displacement both along x and y axis. At that time, displacement it is given by represented by delta r, vector delta r. Vector delta r is equal to delta x I cap plus delta x j cap is the displacement vector. Delta r indicates displacement vector in two dimension or three dimension. Now here you take two dimension, therefore you take only two coordinates, delta x I cap plus delta y j cap. Yes, now delta r is equal to magnitude under root of delta x square plus delta y square. And then direction tan theta is equal to delta y by delta x, then theta is equal to tan inverse of delta y by delta x. Like that, displacement vector. This is second thing. Third point, velocity vector. When you come to the velocity vector, at that time there are two types of velocity: average velocity, instantaneous velocity. Now average velocity, it is given by, how you got this one, average velocity? Average velocity is equal to what you got, delta r by delta t, like this, delta r by delta t. Then you have to take here delta x by delta t, delta y by delta t. You got, that is average velocity along x axis, px bar. You got px bar. There you take in the last class, this is delta x by delta t I cap plus delta y by delta t j cap. Now here average velocity is equal to px bar I cap plus, that is py bar j cap. This is velocity vector. Well, what about the magnitude? A is equal to under root of px bar square plus py bar square. What is the tan theta? Tan theta is equal to, that is py divided by px bar, like this. This is about average velocity. Then instantaneous velocity. When you take the instantaneous velocity, it is the limiting value of average velocity. At that time you take limiting value of average velocity. Once you got the velocity vector, that is an instantaneous value, you take the limiting value at that time, that is v is equal to, that is limit of delta t tends to 0, delta r divided by delta t. It becomes dr by dt is equal to dr by dt. This you got, p is equal to px I cap plus py j cap, like this you got. Now p is equal to under root of px square plus py square. Then tan theta is equal to py by px. This is about instantaneous velocity. It is the limiting value of the average velocity. That is called instantaneous velocity. These things I have to discuss in the, what you take in the previous video clip. Yes, fine. Now you come to the last point is, first point is position vector, second point is displacement vector, and third point is velocity vector. Fourth point we discuss in this video clip clearly, that is said to be acceleration vector. Acceleration vector. Now see here, in the acceleration vector, you take the velocity time graph, velocity and time. You take the velocity along y-axis and time along x-axis. Now the body is moved from this point to this point. This is P to P dash. P to P dash. Now that is equal to here. What you got here? Average acceleration is nothing but it is the ratio of the change in the velocity to time taken, or you said to be change in the velocity per time taken. Whatever the change in the velocity divided by total time taken. Okay. Now average acceleration is equal to change in the velocity divided by time. Yes, fine. Now see, in this case, this is for average acceleration. Average acceleration is nothing but delta v is not tends to 0. Delta v is not tends to 0. Delta t is also not tends to 0. The big value of change in velocity, now more time, big time, more time. At that time you take average acceleration. Now in this graph you see here, there is a change in the velocity when at point P the particle having the velocity v. At point P dash, particle having the velocity P dash, there is change in velocity. Now here P dash is nothing but final velocity. It is the final velocity. This is said to be initial velocity. Now you take the parallel to this one. You take parallel to this one. You draw parallel to this one. Yes, this is B. This is B. And the parallel to this one. This is B dash. Now you join this one. This is equal to B dash minus B. This indicates change in the velocity. You join this head to this head. It gives the change in the velocity. Difference in the velocity of final velocity minus initial velocity is nothing but change in the velocity when more time is you take. It is not tends to 0. The more time, there is more change in the velocity. When average acceleration is change in the velocity divided by time taken. Now this is change in the velocity. If change in the velocity takes place both along x and y axis, therefore delta Vx I cap plus delta Vy j cap. Now average acceleration is equal to delta Px divided by delta t I cap plus delta Vy divided by delta t into j cap. Now average acceleration is equal to that is average acceleration along x axis plus into I cap average acceleration along y axis into j cap. Now this is ax bar is delta Vx divided by delta t is nothing but average acceleration along x axis. Now see ay bar, this is equal to delta Vy divided by delta t. This is average acceleration along y axis. This is average acceleration along, that is y axis. Now this is the expression for the average acceleration. If you got the magnitude, average acceleration is equal to under root of ax bar square plus ay bar square. Now tan theta is equal to ay divided by ay divided by at. Ay divided by at. Average acceleration along y axis divided by average acceleration along x axis. You got the theta. If you got theta is equal to tan inverse of, that is ay divided by ax. This is about average acceleration. Yes, to come to the instantaneous acceleration. What about this instantaneous acceleration? Now in the instantaneous acceleration, delta v tends to 0, delta t tends to 0, but not equal to 0. But not equal to 0. It is only tends to 0. It is not equal to 0. It is only, you say, tends to 0, but not equal to 0. When it tends to 0, you take this point at this point only. This is the direction of the velocity, instantaneous velocity, and this is the direction of the acceleration. The acceleration is always along the direction of the change in the velocity. In what direction change in the velocity? In that direction there is a acceleration. ಯಾವ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ವೆಲಾಸಿಟಿ ಚೇಂಜ್ ಆಗಿರುತ್ತದೋ ಅದೇ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಆಕ್ಸಲರೇಷನ್ ಇರುತ್ತೆ. 2 dimension. Now instantaneous acceleration, it is the limiting value of the average acceleration of the particle. It is limiting value of average acceleration of the moving particle. Now that is the acceleration, instantaneous acceleration is limit of delta t tends to 0, change in the velocity divided by time taken. This is the dv by dt. dv by dt is nothing but what to say, that is the instantaneous acceleration. Instantaneous velocity is v is equal to dr by dt. Instantaneous acceleration is dv by dt. Since dv delta v is equal to delta vx I cap plus delta vy j cap. Now a is equal to limit of delta t tends to 0, delta vx I cap plus delta vy j cap delta t. Now expand this, the limit of delta t tends to 0, delta vx divided by delta t I cap plus limit delta t tends to 0, delta vy by delta t j cap. Now this is vector A is equal to dvx divided by dt. dv divided by dt indicates acceleration. dr by dt indicates the velocity. dvx divided by dt I cap plus dvy divided by dt j cap. Now vector a is equal to ax I cap plus ay j cap. It is the expression for instantaneous acceleration. It is the expression for average acceleration. It is the average acceleration along x-axis, average acceleration along y-axis. Here, this is instantaneous acceleration along x-axis, instantaneous acceleration along y-axis. Ax is equal to dvx divided by dt, ay is equal to dvy divided by dt. Now this is instantaneous acceleration along x-axis, this is instantaneous acceleration along y-axis. Now what about the magnitude? It's very very important. Similar steps you got here. Yes, a is equal to under root of ax square plus ay square. Tan theta is equal to ay by ax. If you want to take theta you got that is tan inverse of that is ay by ax. This is about instantaneous acceleration. Yes, once again I repeat. When a particle moves with the two-dimensional motion, it means the particle is in the state of motion, change with the two coordinates, then it is said to be two-dimensional motion. Either it move in a xy plane or yz plane or xz plane, xy plane, yz plane or xz plane. But here, whatever I have discussed, important 4 points, in all the 4 points, the particle move in a xy plane. First point is position vector. There are 3 equations. Second one is displacement vector. Again 3 equations. Third one is velocity vector. Again this is the average velocity and instantaneous velocity. And fourth one is acceleration vector. Today in this video clip I will discuss clearly in detail yes, average acceleration and instantaneous acceleration. Okay, there are 4 points: position vector, displacement vector, velocity vector and acceleration vector. These are the important 4 points, and in each and every case there are 3 equations. Now, what are the examples for the two-dimensional motion? When you take the turn on the ground, the bicycle or a car on left side or right side, it is a two-dimensional motion. Now, rotating fan is a two-dimensional motion. Rotating fan is said to be two-dimensional motion. Any particle is moving in a circular path is the two-dimensional motion. Electron move around the nucleus in the atom, two-dimensional motion. It's just pointer. This is about the two-dimensional motion. Yes, the very important point to come to that point is said to be that is the projectile motion. What is say? That is projectile motion. What is projectile motion? Very important. Projectile motion of the particle is two-dimensional motion. It is one of the best example for two-dimensional motion. Two-dimensional motion here. This is one good example. ಯಾವ projectile motion. What is projectile motion? What do you give the example for the projectile motion? Okay, what is projectile motion? Any body or a particle thrown in the space. When thrown in the space, now it is moved in a curved path. It is moved in a curved path due to the effect of gravity. This is called projectile motion. Example for projectile motion. Other example: javelin throw, shot put throw, throw ball. It is more like this. It is more like this. When you throw the body, this body is moved like this. This is said to be two-dimensional motion. Throw ball. a cricket ball struck by the bat, then it is moved like this, move like this. It move due to the effect of gravity. It is moving due to the effect of gravity. Suppose there is no gravity is there, it move like this. It move in a circular path or circular curved path due to the effect of gravity. Now this is example for the projectile motion. The path followed by the projectile. The path followed by the projectile motion is called trajectory. Once again I repeat, the path followed by the projectile is called trajectory. Path followed means like this. Suppose it is move like this, path forward. This is said to be trajectory. What is the shape of the trajectory of the projectile motion? Very important point. That is said to be parabola. In conic section, there are different types of ellipse. In conic section, ellipse, hyperbola, and parabola. Now, this is the shape of the trajectory in the projectile motion. It is in the shape of parabola. This is parabola. You show that is a parabola. That is the equation in the form of x plus dx square as a parabola equation. Then in next video clip, I want to discuss about that point. You show that trajectory of projectile motion is parabola. And prove ಮಾಡಬೇಕು. ಈಗ ಪಾರ್ಟಿಕಲ್ ಇಸ್ ಮೂವಿಂಗ್ ಇನ್ ಪ್ರೊಜೆಕ್ಟೈಲ್ ಮೋಷನ್ ಅಂದಾಗ ಅದು ಏನು ಅಂತ ಇರ್ತದೆ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಅದು ಪ್ಯಾರಾಬೋಲಾ ಶೇಪ್ ಇರ್ತದೆ ಅಂತ ನಾವೇನು ಮಾಡಬೇಕಾಗುತ್ತೆ ಅಂದರೆ ಪ್ರೂವ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಎಸ್. Now see here, there is so many examples for the projectile motion. So many examples. Now this one, the launching vehicle. Your satellite is launched by the launching vehicle. That launching vehicle is moved with a certain angle here. It is moved in a projectile motion. Okay. Yes. Now see here. This is the projectile motion diagram. This is the projectile motion diagram. It is in xy plane. XY plane. Now the body is projected at this point. The body is projected at this point in this direction with a certain velocity. With a certain velocity. Or you say V R U, whatever you have to take it. With velocity. Now it is moving in this direction. It is in parabola shape in a xy plane. It is a two-dimensional motion. Yes. Now see here, a body is projected in the space with a certain velocity. This is called velocity of the projection. The body is projected in the space with a certain velocity is called velocity of the projection. No, the body is projected with a certain velocity with a certain angle to the horizontal. ಈ ಬಾಡಿನ ಹಿಂಗೆ ಪ್ರೊಜೆಕ್ಟ್ ಮಾಡ್ತಾನೆ. ಹಿಂಗೆ ಪ್ರೊಜೆಕ್ಟ್ ಮಾಡಿದಾಗ ಹಾರಿಜಾಂಟಲ್ಗೆ ಎಷ್ಟೋ ಆ್ಯಂಗಲ್ ಒಳಗೆ ಪ್ರೊಜೆಕ್ಟ್ ಮಾಡ್ತಾನೆ ಅಂತ ತಿಳ್ಕೊ. ವಾಟ್ ಎವರ್ ದ ಆ್ಯಂಗಲ್ ದ ಬಾಡಿ ಇಸ್ ಪ್ರೊಜೆಕ್ಟೆಡ್ ವಿತ್ ಸರ್ಟನ್ ಆ್ಯಂಗಲ್ ಟು ದ ಹಾರಿಜಾಂಟಲ್. ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆ್ಯಂಗಲ್ ಆಫ್ ಪ್ರೊಜೆಕ್ಷನ್. ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆ್ಯಂಗಲ್ ಆಫ್ ಪ್ರೊಜೆಕ್ಷನ್. ಇದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಆ್ಯಂಗಲ್ ಆಫ್ ಪ್ರೊಜೆಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. This is said to be angle of projection. First is velocity of the projection. The velocity with which the given to the body when it is projected in the space, that is called velocity of the projection. And the body is projected in the space with certain angle to the horizontal. This is called angle of the projection. Now this body is moving in this projectile motion in the parabola path. Maximum vertical distance covered by the projectile is called height of the projectile. Maximum horizontal distance covered by the projectile from the place of the projection in the time is equal to time of flight. This is called range of the projectile. Maximum horizontal distance covered by the projectile in time is equal to time of flight. This is called range of the projectile. Now the total time taken by the projectile to reach the reference surface. This is the reference surface. Now it is projected from the reference surface. Again it is the reference surface with certain horizontal distance. That time is called time of flight. Now t plus t is 2t. Now small letter t, this is you said to be, first t is said to be time for ascent. Next time t, time for descent. In the absence of air, resistance, there is no friction. Whatever the time for ascent is equal to time for descent. ಹೀಗೆ ಪ್ರೊಜೆಕ್ಟೈಲ್ ಮೋಷನ್ ಇಂದಾಗ ಮೇಲೆ ಹೋಗಲಿಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ತದೋ ಕೆಳಗೆ ಬಂದಲ್ಲಿ ರೀಚ್ ಆಗಲಿಕ್ಕೆ ಅಷ್ಟೇ ಟೈಮ್. ನಾವು ಟೈಮ್ ಟೇಕನ್ ಫಾರ್ ಅಸೆಂಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಟೈಮ್ ಟೇಕನ್ ಫಾರ್ ಡಿಸೆಂಟ್. ಓಕೆ, now see here, this is a very important concept here. I want to discuss one more point, the velocity of the projectile motion, that is resolved into two components according to resolution of a vector. That velocity of the projection is split up into two components. Now one of the component along horizontal, another component is along the vertical. Suppose at any point this velocity is resolved into two components. One component along x-axis, another component along y-axis. Along horizontal component p cos theta. It is along x-axis. Now vertical component, that is p sin theta, along that is y-axis. Now this is the resolution of a vector. This is the velocity is the vector. Now it is resolved into two components at any position in the projectile motion. Yes. ಹೀಗಿರಲಿ ಈ ಪಾಯಿಂಟಲ್ಲಿ ನಾವು ಎರಡು ಕಾಂಪೋನೆಂಟ್ ಆಗಿ ನಾವು ಸ್ಪ್ಲಿಟ್ ಮಾಡಿದರೆ, ರಿಸಾಲ್ವ್ ಮಾಡಿದರೆ, ಒನ್ ಆಫ್ ದ ಕಾಂಪೋನೆಂಟ್ ಅಲಾಂಗ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ horizontal, another component is vertical. Throughout the projectile motion, this is a very important point. Throughout the projectile motion, horizontal component, there is no change in the direction of the horizontal component p cos theta, or you say u cos theta. U thrown u cos theta, p thrown p cos theta, and also it is uniform. Now the component of the velocity of the projection along the horizontal, it is in the same direction. Also it is uniform. It is same direction uniform. But vertical component p sin theta, it is non-uniform. P sin theta is non-uniform and also change its direction when for ascent and descent. The vertical component phi sin theta, that is the varies, changes. When for ascent go on decreases, when for descent go on increases, and also change the direction. When in the projectile motion for ascent it is in upward direction. Now this is for descent in a downward direction, but px is along the same direction. And the particle reach the maximum height of the projectile. Here this component becomes zero, u sin theta, p sin theta. This vertical component becomes zero, but it is having only horizontal component. ಹೀಗೆ ಹೋಗ್ಬೇಕಾದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬಂದಾಗ ಹಾರಿಜಾಂಟಲ್ ಅಷ್ಟೇ ಇರ್ತದೆ. ಸ್ವಲ್ಪ ಹೊತ್ತು ಮುಂದಾದ್ಮೇಲೆ ಮತ್ತೆ ಎರಡು ಕಂಪೋನೆಂಟ್. Once again repeat, the velocity of the projection is resolved into two components at any position in the projectile motion. One of the component along x-axis, that is cos theta component, v cos theta, it is along the same direction and also uniform. Another component is vertical component. It is a v sin theta. It is v sin theta. This is point. This is the v sin theta. Now it is varies. When for ascent, go on decreases. When for descent, go on increases. And also change the direction. When for ascent in upward direction, this is for descent downward direction. This is point. Now this is about projectile motion. What is the velocity of the projection? Time of flight, all these things. Okay, once again I request to all the students, you become a subscriber for our channel. You press the subscriber button and you press the bell button. You become a subscriber. And you have more point to say in this graph. It is a velocity direction, it is acceleration direction. Instantaneous velocity is instantaneous acceleration. Now change is the acceleration is always along the direction of the change in the velocity. Okay, thank you. ಸಬ್ಸ್ಕ್ರೈಬರ್ ಆಗಿ ಎಲ್ಲರೂ ಥ್ಯಾಂಕ್ ಯು.